short, what is redundancy airfield lighting? What is the difference between redundancy airfield lighting and the backup airfield lighting? And then I will try to talk about financial losses that can be caused by blackouts or failures of the main AGL, how S4GA redundancy AGL can protect against those blackouts, and then I will try to talk also about additional benefits for the redundancy airfield lighting, which is saving the money on a regular basis on a daily operations, and additional profit of the CO2 emission reduction, the carbon footprint. Conclusions and Q&A session. It's pretty much the plan for today. So I will start with who we are and what do we do. S4GA is a manufacturer, designer, and supplier of certified airfield lighting. We supply to civil and military customers worldwide. As you can see on the pictures, we have manufacturing plant. We actually have a training center here on the right, the picture of the building. And on the bottom, you have one of the examples of the installations that we have done. S4GA, so basically, what should you remember about S4GA in a very nutshell, in a short? S4GA is a manufacturer of world's safest runway lighting. It's a very big topic. I will not cover this in the presentation today. It's actually part of another presentation about 5 steps of protection against the system failure. But in a very short, S4GA systems are the world's safest and world's most reliable airfield lighting systems available. The company is government owned. So the major shareholder of the company is Polish state, and all our products are certified in accordance with various regulatory bodies. For example, ICAO compliance certification is available for all S4GA products. That also can be found on the website. So today, as of November 2020, S4GA is in fact 130 projects and installations in more than 50 countries worldwide. As you can see, the map is pretty wide and we are covering almost all continents, I believe, maybe not Antarctica yet. But this is what company is in the, let's say, in the stage of the development. And we have so many installations already delivered, and they are not only, as you can see, in the area of equator, as many would think for the solar airfield lighting to be only applicable. I think some of you can see an installation in Yukon in Canada, very up north. We have a lot of installations that are not obvious for solar systems. Few pictures from our installations worldwide, from Uzbekistan, Ethiopia, regional airport, Maldives, a regional airport, Lithuania, a regional airport, a temporary system in Greece, a system in Argentina. So this is just a flavor, just for you to see what type of projects we have done in the past. So what actually are we capable of doing? And now let's jump into the topic of today's presentation, redundancy airfield lighting. I will read with you the definition and elaborate a little bit about it. So redundancy airfield lighting is a backup airfield lighting system permanently installed in parallel to the existing conventional AGL. As you can see here on the picture, this actually is a S4GA system installed in parallel to a conventional runway lighting. The system increases the safety of the flight operation, secures the airport from the financial losses related to unexpected airfield lighting blackout. But not only, it also allows to save the money on the daily operations by not forcing the airport to use the primary system 100% of the time. And I will talk about it a bit later after I will cover the topic of the blackouts. So when you think about it, how it would look like, we would have two rows of the lights. One would be the primary system, the AGL conventional 6.6 system, and the other one would be the redundancy that would in fact be just standing next to the already cabled wired solution. Now, we would like to run a short poll, if you allow, just 1 minute to get your feedback, your opinion about the topic. And later on, we'll share also the result of the poll with you at the end of the presentation. So I think, Olga, please run the poll. Okay, I can see that about 70% of the participants have already voted. So I will close the poll now and you will be able to see the results. And I'll just quickly go with you through the results. So the first question was, do you agree that sudden loss of runway illumination can cause serious financial losses? Almost everyone has agreed that this would be the case. Then the second question is, do you agree that every single airport, despite its size, passenger capacity, or investments, is under the risk of sudden runway lighting blackouts? And this already is not such an obvious answer. Here, about 70% of the people agreed that yes, it would be the situation, but about 30% of the people, so 1/3, would think no, modern airports are equipped with so many backup systems that this basically is not an option or would not happen. Now, this is also an interesting question. In your opinion, how much money will an airport lose in an average case of emergency runway closure or emergency runway closure? And here we have more than 1 million, is only 14%. So actually, we don't have a winner here. I think something between 50 and 1 million. And many of you just won't know, actually. This is where we are when we are looking at the answers. We did this poll because, of course, on the next slides, we'll have some of the answers or some of the perception from our side. So let me close the poll. And continue with the presentation. Just a quick question. Can you still see my screen?
No.
Whoever is keeping their mic on, please mute your mic, if possible. Sorry, I'll just jump back to the previous slide. Ladies and gentlemen, over the last 10 years, high traffic airports have experienced runway blackout. Actually, the number here, given the 50, is what is public information, what is available in the media. This is the information that can be found by anyone. It's not only available to industry specialists. It's basically in a public domain. And we are speaking now, when we are talking about the 50 high traffic airports over 10 years, maybe it doesn't sound a very high number, because it's only 5 airports by year, if you think about it. But the overall number only for the last 5 years is 37. And you would maybe think that Europe will not be so much impacted by this event. I'm talking about complete airfield lighting blackout. So a situation when a relatively big international airport is experiencing an unexpected loss of runway lighting. So the number for the airports in Europe is 7. So 7 airports have suffered such situation. Now the 20 cancelled flights in each and average, it's an average, so it's not a very good number, but it's a number that is giving some flavor on potential impact of the operations. In one case it will be 200, in another case it will be 1. 20 is an average. Again, it's not a perfect number, but I think what is here the most striking is the value in US dollars. Again, it's a kind of approximation. This information is done on certain assumptions. I will talk about it in a moment, but it's a number by average between 250 to $1 million US dollars. So actually, an unexpected loss of an airfield lighting may be quite painful for an airport. And I will explain this a little bit more in next slides. I think this is the map showing more of the airports that suffered. Not all of them, just major ones. And I think what is visible from this map is the following conclusions. The unexpected loss of an airfield lighting, or major airfield lighting failure, is not related to any specific continent. It's not related to any specific brand of the conventional lighting installed. It's also not related to a region of the world. It's basically it's a situation that can happen to everyone or to every airport, and I think it's also regardless of the investment that would be done for the airfield lighting in a particular airport. It just can happen to everyone. And this map is just presenting this in a more, let's say, visual way. Now we have a backup for this list, and it will be this particular slide. I think many of you will be able to find some of the cases that you know very well. And I'm not going to focus so much on the losses of the airport here, because we did the calculation in S4GA based on some assumptions that we have also found in the industry. One of which is that, let's say, an average aeroplane would bring about 10,000 US revenue to an airport. But again, it's an average. So it's averaging a ATR 72 and at 777. So it's not a perfect number, but take into account the quantity of operations and the average number of loss of the revenue from the airport side, including landing fees and the fuel, etc., etc. We are coming to numbers that you can see here. As you can see, also for many of those airports, we don't have the numbers, so we were not able to present them. So it's maybe better to see the consequences column, where we can see that the average situation lasted not in minutes, but in hours, and in very few cases, days. And the numbers of flights that were cancelled is in the range between 10, 20, and higher. So we are not talking about the situation when we are losing a single flight or 2 flights during this particular situation. This table, of course, is available, and we will be able to share it. Whoever would like to know the source that we are presenting the table here, it will be available. Please contact me after the presentation, but we just weren't able to present the source here because the table would be unreadable. But all this information is actually coming from available media publications, so public domain. Now maybe another view on the topic. So I will focus on a few of those airports. Atlanta International Airport, a huge airport. That's one of the biggest cases that happened with almost 12 hours of runway unavailability from 2017. So we would say quite fresh situation. Another situation, a failure in Heathrow, maybe not so significant, but this is still something that appeared. We have another airport in Brazil. So as you can see, even looking at this short zoom, the numbers can vary from millions to hundreds of thousands, but they are not really in dozens of thousands. So for an international airport, unexpected loss of an airfield lighting is a serious matter, and it's costing money by minutes because there is so much traffic coming in and being diverted or put on hold and later diverted. What we are looking at in, let's say, overall is probably this type of range. So 250,000 US. Again, for maybe a smaller airport, it will be in a range of 100,000. For an average international airport, maybe 500,000. We don't know the exact number, but this is the number that is undeniable in the sense of looking only at the statistics and the hours of unavailability of the runway. This is where we are. 250,000 to 1 million potential loss from just one single event. So I was talking about the scary situation. I believe that for some of you that built some questions, even controversy, we'll be happy to talk about it. I will talk a little bit about the solution. So, redundancy airfield lighting. Again, this is a cut-to approach to an international airport. And what S4GA has to offer is ICAO and EASA airfield lighting compliant, independent from an airport electrical network with the built-in batteries inside, and powered by solar energy. All this system installed in parallel to conventional system can be controlled via a control and monitoring system installed in a tower. Also, S4GA system can be integrated into a CMS of an existing system. So in case of a failure, the switch over time would be counted in seconds, meeting the ICAO and FAA requirements for such situation. Short movie, maybe a little bit bringing this to a life, just not the pictures. Hope you're gonna like it. So now we have an approach. The main system is down and the backup system is on. So as you can see, even from the tests that we have performed in an international airport, and this was not a fully integrated system, the solution here was, I think, 2 or 3 seconds when the redundancy system has kicked in. And from the perspective of the airport, they would be able to continue the operations under certain operation limitations. Here is again a summary of various products that we would be able to offer to an airport in order to address the situation. So coming from the top, runway end light or threshold end light, and both are available. Runway edge light, threshold light, approach lights. Also, we can equip a taxiway lights, and most important, all this can be controlled from a dedicated control and monitoring system that is installed in a tower. No wires are required, no digging, no installation that would require any connection to an existing 6.6 system is required. The system is autonomous, can be operated 365 days a year. And this is, of course, a topic for another presentation, but the availability of the system, depending on the location and operational restrictions, is quite big. I'm talking about the system autonomy. Up to even 24 hours, 7 every day, 365, the system could be operating. Of course, it's not necessary to do it, but this is the operational ability, technical ability of the system to work. So, to summary on this one, on this topic, the airports, international airports, operating flights every day in case of a failure would be able to save safely, maybe 250, and in a worst case scenario, maybe $1 million or over $1 million US by having a redundancy airfield lighting. I think you will have a lot of questions to that, so we'll jump into the Q&A session in the presentation. But this topic on probability of the failure, the impact of the failure, and the installation of the parallel AGL system is, of course, a topic unable to be covered shortly in the presentation, but at least we will be able to engage into a discussion in the Q&A session. Now, I will talk a little bit about additional benefits of the system. Now, saving money on electrical bills. This is just a visualization of a standard approach, runway with the Cat 1 approach on one side and Cat 2 approach on the other side. So actually, what are we talking about the use of the electricity on such a runway, assuming 12-hour operation per day, 365. So we would be talking about 996,000 kilowatt of energy to be consumed. And this is made on the assumption that this is a halogen runway. So I think this is the question which you would like to ask. Yes, the calculation here is made on a halogen system. Now, by calculation, the average cost, annual cost for running such a runway, 12 hours daily, would be about 200,000 US. So this is one of the things that we have noticed by speaking to our customers over the years, is that the exact cost of operating airfield lighting in terms of a bill, electrical bill, is quite often unavailable or unknown to an airport. Why? Because these bills are usually together with the electrical bill for a terminal site, and therefore this number is a little bit diluted and unable, and no one very quickly is able to say, unless this topic is a focus on a particular airport, what is the cost of annual cost of running a runway. Now, this number, of course, can vary, and it will vary significantly depending on the types of the operations and how long the airfield lighting is on. But we would be talking, this is an average number here, assuming 19 euro cents per kilowatt hour, and assuming 12 hours of operation daily. Of course, assuming that most of the operation would be actually happening on the preferred runway side, which is the Cat 2 side. And even if you wouldn't have a Cat 2 conditions, you would have still the Cat 2 approach mostly used and illuminated. So in one case, this number can be probably as close as a 500,000. In another case, it will be maybe 100,000, but this is probably the area that we would be looking at. So now, what and how can we save money with S4GA redundancy airfield lighting? If we already have the system installed on the runway, and it's already there, sitting and waiting for potential failure to happen. Sorry to say, but that's really how that would happen. That would be the truth about the reason why the system is primarily installed. But if it's there already working and waiting for a chance to operate, it can also support the airport during a limited amount of operations which are related to a relatively good weather conditions, where there is no requirement for operating a precision approach and illuminating the runway with Cat 2 or Cat 1 illumination. So we are, in a way, we are substituting the permanent system, the primary system, with the redundancy system that is certified up to a non-precision approach. So in fact, even a VOR approach could be safely shot using only S4GA redundancy airfield lighting in line with the in the compliance with the existing regulations. So if you take into account that you would be able to operate the solar powered system 10, 20, 30, 40% of the time, you would account a visible, a tangible savings. We calculated here 50 to 150,000. It really, again, depends on the airport, how much time they would like to use it, and how much time it would be, what would be the cost of the electricity in a particular airport or region. But in a nutshell, this is absolutely feasible, and the airport could be saving real money by using the redundancy system during, let's call it a better or good weather operations, because the airfield would not need to be eliminated with relatively expensive to operate main and primary wired system. Second, positive impact on the airport operation is the carbon emission. This is a topic that is not quantified so much in US dollars, and it's not so much related to immediate savings in terms of money, but there is a significant sorry to I just flip the slide. There's a significant impact on the potential carbon and zero emission aspect, and many of the airports today are looking into this topic of zero emission and receiving a certificate for, or bringing them closer to the certificate for the zero emission and greener airports. I think this is the subject that we are now talking about. ACI, Airport Carbon Accreditation Program, is already in place. It's happening. S4GA is also part of the ACI Africa, and with our solution, we are able to support the airport in bringing them closer to achieving the goal of the carbon neutrality and greener airports. So again, it's maybe not immediate profit in terms of US, but this definitely works positive from the concept of the greener airport, which is now a worldwide trend. So a summary: redundancy airfield lighting. What it will do. Just one more summary of the solar energy and green airports. Solar S4GA redundancy airfield lighting is protecting and saving the airport in case of a main AGL blackout. Very low probability, but there is one, and the money involved here between 250 to $1 million US. But that's not only the case. Also, the airport can save on daily, yearly operations in terms of the electrical bill, which would be in a range between 50, 150, and probably even more in high electricity cost locations. And these savings are available basically immediately after the system is installed. So in case of a number one situation, we are looking for a black swan that may or may not happen. But in the case of a second effect, we are actually saving the money immediately. And the third is basically the aspect of the green airport, carbon neutrality subject and topic discussed and pushed worldwide today. And S4GA solution will bring you closer to the target. I think from the perspective of this presentation, I briefly covered all the topic. I just would like to remind to many of you who didn't join yet that S4GA has a academy program, training program available. If you join our website, on the website you will find a link just on the top, S4GA Academy. Please sign in. It's actually about 3-hour program with tests and questions that finish with the certification, initial certification to understand better and grow in a solar airfield lighting subjects. I think for some of you it might be an interesting thing to do. So now I have finished the presentation part and I'm quite eagerly looking for the questions. Sorry, I will do the poll again after the presentation is finished. We'll run a quick poll again and then we'll do the Q&A session. So fire away, Olga. Okay, I think we have most of the people already voted. And a quick view on the results of the presentation. I think of the presentation, do you agree with the benefits of the redundancy airfield lighting for high traffic airports that have been presented? I would say 80%, so quite a large number has agreed on the general concept. And now going into the details. What benefit of redundancy AGL do you find most useful? So I think quite an interesting question. And now, 1/4 of the participants say it's keeping the runway operational. Half of the participants said, okay, all of them are important. And I saw basically almost 80% of the people are looking that either this is operational continuity of the airport is most important, and the money part is also important in a case of 50% of the participants. So that's how I'm looking at those results. Again, thank you for the participation. They are very useful for us. It's a feedback information, or instant feedback information. So thank you for your time and for clicking for it. Now I will open the chat and try to answer the questions that we have been asked during the presentation, and of course you are free to ask the questions also after I will give the answers now. So yeah. Question number 1, can we share the presentation? The presentation will be published on YouTube as a part of the process that we have. If you are looking for the presentation, exact presentation that I give today in a PowerPoint, please contact me directly after the webinar. So I can see here only from Simon Robinson, is the system certified for category 1? The system is certified for category 1. S4GA it has a unique advantage. We actually have high intensity solar airfield lighting available. If you go to our website, you will see the certification and the products on the basically on the screen. Next question. What is the average lifetime of the S4GA lights, including battery and mean time between failures. I think the mean time between failures question I will not be able to answer. I don't have it out of the top of my head. I know that this topic is covered and we have a certification and calculation done, but I don't remember. So if you really are interested, please contact me and I will give you the information regarding the average lifetime of S4GA lights, including battery. I'm thinking, I'm not 100% sure, but I'm thinking you're asking me how often the lights require replacement of the battery. And this is a very valid question. By average, standard battery would require a replacement every 2 years. This is a standard battery. We have a higher quality battery that will require the replacement around every 4 years. But the price is higher, and typically this battery is used in extreme temperature locations, either very high temperatures or very low temperatures. So what is actually unique for S4GA is not how often or not you have to replace the battery, because the battery in the systems like S4GA have to be replaced, and this is non-negotiable fact. But the system, the CMS system, the control and monitoring system delivered with the entire solution is actually giving the exact information and quite accurate information to the user when those batteries should be replaced. I say 2 years, but that can be even 3 years, or that can be less than 2 years, assuming certain utilization of the system. But the CMS system is monitoring the cycles and the time and the discharge cycles of the battery and advising the preventive maintenance for the user. So this is, again, a unique feature from S4GA control and monitoring system, and of course, typically used by the maintenance people. So in order to address the problem of the batteries, you know exactly when to replace them to avoid any potential issues relating to battery damage. Is there any other question from the team, or okay, we have another one. You have a solar and portable lights in the product portfolio given on your website. Why not to use portable fixture as a redundancy illumination? Okay, I think we are speaking about two different applications, two different solutions. So when talking about portable systems and redundancy systems, they serve a different purpose. A redundancy system is permanently installed and is actually sitting on the runway all the time. And in a way, it's waiting for a potential failure to happen. That's one thing. And also by using it certain amount of time, allowing to save the money for the airport during regular operations. The lights are bolted to the tarmac. The lights are basically serving as a second complete solution airfield lighting that is available at any time for the user. The portable lights are typically a solution that you would only use in case of a failure, and you would take a trailer, you would take a car, and you would actually use quite a lot of time, maybe 20 minutes, maybe 30 minutes, maybe 40 minutes to put them on the runway. It is possible, it will serve the same purpose. At the end, you will have an illuminated runway. But the switch over time in case of portable lights will be much longer, and international airports, the 40 minutes already counts for a significant loss. And second of all, the portable lights are not equipped with solar panels, so they would be typically battery-powered lights. They would not be charging. So if the potential failure would last for more than a week or two, you would need to actually charge them. So not a perfect solution for this particular application that is an international airport, even though for many reasons you can imagine that the portable solution can be used, but it is serving a different purpose. And of course, it will not be a solution for saving money on a daily operations, because these lights would not be fixed to the ground and would not charge. So they would require charging. That means they would require to be removed for the time of the charging. Now, next question. What is the maximal usage time of Cat1 operation before the battery runs out, and how many times you need to reload? Now, I think I understand the question number one. So there are actually two questions in this question, but I will try to answer. So what is the maximum usage of the Cat1 operations? So I need to ask a question back, which would be, and what power settings are you looking to use the Cat1 fixture? Because the time of operation for the Cat1 fixture would significantly depend on the setting that you would set. Is it 100%? Is it a 60%? Is it a 10%? 3%? It really depends. And then the question number two is how many times you need to reload. This I don't really understand. So can you elaborate a little bit more? What do you mean? Do you need to reload? How many times? Now, Alexander, you answered 100%. That was what I was thinking that you would do. I would answer like this. In case of S4GA airfield lighting, even if you would install a Cat1 high intensity runway light on a runway, so you would in fact have two parallel runways that would be both Cat1, you would not use the S4GA system on a maximum setting, because this system as a redundancy system would be only available up to a non-precision approaches. So in fact, if we are talking about non-precision approaches, that means that your light would not require and could not be even set to 100%, because 100% is only typically used in a very bad weather conditions of category 1, when you have visibility 550 and a ceiling of 60 feet. So, and then you use the 100% setting. So coming back, in case of S4GA lights, even though you would be able to do it, you wouldn't do it, because you would most likely be using the light at negative intensity. It is about 1,500 candelas, 2,000 candelas, and this is about 20% intensity. So the operating time in this case would be probably 50, 60 hours. If you need to use it at 100%, you would still be able to do it in case of emergency. And this operating time for a standard battery would be 8 to 10 hours. So still quite in line. If you look at the previous slides, if you remember the previous slides, how much time did it take for an average airport to fix the conventional lighting? It was, most of the cases did not exceed 10 hours. And S4GA lighting would be able to cover for 10 hours at maximum intensity, again, which would most likely not be used in the case when this lighting would be in operation. Do we have any other questions? Michael, the answer is, in short, yes, it could be used. So maybe I read the answer out loud, the question out loud. Is it possible to use S4GA system with no mains light system for VFR GA night landing for training flight? It can be used in international airports, so it can be used on a GA VFR flights too. Moshin, can the batteries be replaced easily, or is it requiring some training? No, it doesn't require a training, and they can be replaced very easy. It takes about 5 minutes. And on the YouTube S4GA channel, you can find a video explaining step by step how to replace the battery. But I think even more cool about S4GA is that we are using a worldwide standard battery that you can purchase locally in a country. You don't need to buy them from S4GA directly, because typically they will be heavy and bulky, and shipping them half of the world doesn't always make sense. So when talking about replacing the battery, S4GA is an easy case. And most important, those batteries are available locally as they are worldwide standard. If there is no more questions, I would close the session. As I said, 30 to 60 minutes. I think we managed to cover the topic, at least have a flavor of the initial discussion. Thank you everyone for joining. And again, this material will be published on YouTube, S4GA YouTube channel. Thank you again for your participation. And see you next time on the next webinar. Thank you very much.